There are three main components of a dental X-ray machine: the control panel, the extension arm, and the tube head. The tube head is a tightly sealed heavy metal housing that contains the X-ray tube which produces the dental X-rays. The body of the tube head is made of a metal housing that surrounds the X-ray tube and transformers. The transformers are used to increase and decrease voltage, and the entire housing is filled with an insulating oil. This oil prevents overheating by absorbing the heat produced by X-ray generation. At the opening of the tube head is the tube head seal. This part seals the oil inside the tube head and also acts as a filter for the X-ray beam. The heart of the X-ray generating system is the X-ray tube. This is critical to the production of X-rays. The tube itself is a glass vacuum tube from which all air has been removed. Inside the glass housing are two main components: the cathode, which is the negative electrode. It supplies the electrons needed to generate X-rays. And the anode, which is the positive electrode. Its job is to convert those electrons into X-ray photons. The anode includes a tungsten target, which serves as a focal spot and converts electrons into X-ray photons, and a copper stem, which helps dissipate heat away from the tungsten target. Once the X-rays are produced, they leave the tube head by passing through a series of components. First, they go through aluminum discs, which filter out the low-energy, non-penetrating X-rays. Next, they pass through a lead culminator, which restricts the size and shape of the X-ray beam. Finally, the X-rays exit through the PID, which directs and aims the X-ray beam towards the patient. X-rays are produced when electricity from the wall outlet supplies power through the control panel to the tube head. Inside the tube head, the current is directed to the filament circuit and the step-down transformer, which reduces the voltage from 110 or 220 volts down to 3 to 5 volts. The filament circuit uses this low voltage to heat the tungsten filament in the cathode. As the filament heats up, electrons are released and form an electron cloud around the filament. These electrons remain in the cloud until the high voltage circuit is activated. When the exposure button is pushed, the high voltage is applied and the electrons produced at the cathodes are accelerated across the tube towards the anode. The electrons strike the tungsten target of the anode and their kinetic energy is converted into X-ray energy and heat. About 99% of the energy is heat, which is carried away by the copper stem and absorbed by the insulating oil, while about 1% becomes useful X-rays. The X-rays are then produced and emitted from the target in all directions. The leaded glass housing prevents the X-rays from escaping, except through a small unleaded glass window portion of the tube. From there, the X-rays pass through the tube head seal and aluminum disc, which filter out longer wavelength, non-penetrating X-rays. Next, the X-ray travels through the lead culminator, which restricts the size and shape of the beam. Finally, they pass down the PID and exit the tube head at the opening of the PID, where the X-ray beam is directed towards the patient.